Hello friends, I welcome you all to this new video which is on application of normal distribution. I hope you have watched my previous video on normal distribution. In the previous video I have talked about the concept of normal distribution and normal probability curve. It has to be understood that the basic understanding of normal probability curve and normal distribution is very much essential for a researcher in the field of social sciences and education. In fact, whenever we go to the field and collect data from the field, the data are basically based on human attributes, and when we tabulate the data, we can see that maximum of the time they follow the normal distribution. So if we understand the characteristics of normal distribution and normal probability curve, we can interpret from the tabulated data. We can understand what the data is saying about the sample and the population. We can also use it for different statistical calculation. In this particular video, which is on application of normal distribution, we will be taking up different examples from real life situation where we apply the properties of normal probability curve and we solve the problems very easily. Basically, I will be dividing this video into two parts. That is, this video will be the first part of application of normal distribution, and there will be the second part also, because there are various applications. For good understanding of the viewers, I have taken several problems related to real life situation, and we can see that how the properties of normal probability curve help us to solve these problems. So keep watching. Okay, before we solve the problems based on normal probability curve, we should understand that the normal probability curve is based upon a unique normal curve. That means a normal curve with mean 0 and 1 and sigma 1. But practically this is not the situation. Whenever the n value is quite high, whenever sigma is different from this particular value, or mean is also different, then we have to convert the raw score into some other scores, or we have to convert the raw score into standard score or Z score. So one of the important major formula that we have to use for solving problem on normal distribution is Z equal to x minus m by sigma, or Z equal to small x by sigma. So what are these particular symbol representing? In this, Z is standard score, x is the raw score, m is the mean of x scores, and sigma is standard deviation of x score. So let us take one example. Suppose we have a distribution with mean 25, sigma or standard deviation pi, and x equal to 30, or raw score equal to 30. Then how to get the Z score? So we will use the formula of Z score, Z equal to x minus m by sigma, that is equal to 30 minus 25 by pi, that is 1 sigma. So this is one of the important formula of calculating Z score or standard score. In majority of the problem based on normal distribution, we need to convert the raw score into Z scores. So this formula we will be using it for calculating the standard scores. The other main object or table which is used for solving the problems based on this formula is the table of area or percentage of the entire distribution in correspondence to the Z score or values. The table of areas of normal probability curve are referred to find out the proportion of area between the mean and the Z score. Though the total area under the NPC is 1, but for convenience and for the ease of comprehension and interpretation, the total area under the curve is taken to be 10,000. As this makes it easier with which fractional part of the total area may be then calculated. The first column of the table x by sigma gives distance in tenth of sigma measured off on the baseline for the normal curve from the mean as origin. In the row, x by sigma distance are given to the second place of the decimal. To find the number of cases in the normal distribution between the mean and the ordinate erected at a distance of 1 sigma unit from the mean, we go down the x by sigma column until 1 is reached, and in the next column under 0.00 we take the entry opposite to 1, namely 3413. This figure means that 3413 cases in 10,000 or 34.13% of the entire area in the curve lies between the mean and 1 sigma unit. Similarly, if we have to find the percentage of the distribution between the mean and 1.57 sigma, say we go down the x by sigma column to 1.5, then across horizontally to the column headed by 0.07 and note the entry 4418. 44.18% of the cases lie between mean and 1.57 sigma unit. This table is thus of major use whenever we are in the process of solving problem based on NPC. So this particular table we will refer repeatedly whenever we will be solving problems based on normal probability. This particular table and the formula for standard score or Z score are the two important aspects whenever we are solving problems based on normal distribution. I hope you have understood how to follow this table. If you have not understood or you need practice, then you can rewind the video and again watch it repeatedly, so you will be able to follow how you are using this particular table. Basically, any good book of research has this table, and once you are able to use this particular table and follow it, then you will be able to solve problems based on normal distribution. Okay, after understanding the formula of Z score or standard score and also the process of using the area curve or percentage of cases under a particular Z score and the mean, now we will progress towards different application of normal probability curve. The first application is to determine the percentage of cases in a normal distribution within given limits. So to understand this particular application, to determine percentage of cases in a normal distribution within given limits, we will take a problem. Suppose, for example, in a test, the mean score obtained by the student is 60 and the sigma or standard deviation of the test is 5. Assuming the normality of the distribution, that is, the scores obtained in this particular test are normally distributed, find first percentage of cases falling in between 65 and 55, second percentage of cases above 70, and third percentage of cases below 45. So you can see that this example is based on this particular application. Two or one particular limit is given here. Suppose these two particular scores are given, 65 and 55. We have to find out the percentage of cases in between 65 and 55. We have also have to find out percentage of cases above 70 and also the percentage of cases below 45. So you will see how the characteristics of normal distribution and whatever formula we have studied will be used to solve this particular problem. So we have got our problem. Our problem is written here. In a test, the mean score obtained by the student is 60 and the standard deviation is 5. Assuming the normality of the distribution, we have to find different percentage of cases within some given limit. To solve this problem, I already told you that we have to use the formula of Z score and also the area curve. Another important aspect that we have to use and we have studied in the previous video is the percentage of cases in between different sigma distribution. So let us see again what are the different percentage of cases in between different sigmas or 6 sigma distribution. So this is the normal distribution curve, and if we drop a perpendicular in the center, then we know that 50% of the cases lie in the right hand side and the other 50% of the cases lie in the left hand side. And if we see in between one standard deviation and the mean, 34.13% cases in the both hand side, 34.13% cases lies. So in total, in between plus 1 sigma and minus 1 sigma, 68.26% cases lies. This we have already seen in the previous video. Similarly, in between 1 sigma and 2 sigma, 13.59% cases falls in both the side. You can see in between 1 sigma and 2 sigma 13.59% cases, and similarly in the left hand side minus in between minus 1 sigma and minus 2 sigma 13.59% cases lies. So in total in between minus 2 sigma to plus 2 sigma 95.44% cases lies. Similarly in between 2 sigma and 3 sigma 2.14% of cases lies, and similarly in between minus 2 sigma and minus 3 sigma 2.14% of the cases lies. The remaining cases lies above this 3 sigma value in the both the direction, but almost 100% of the cases or 99.73% of the cases lies in between these 3 sigmas, that is in between minus 3 sigma to plus 3 sigma. So basic understanding of this percentage of cases in between these specific sigma values will be used in solving these problems. Now let us come back and solve our problem. Our problem is, the first part was to find out percentage of cases falling in between 65 and 55. So to solve this particular problem, we can see this is the normal probability curve. Now here our mean is 60 as per the question, and the standard deviation is 5. So first of all, as I already told you, that we need to convert the raw scores, whatever raw score is there, we need to convert into standard score or Z score. That is one of the basic thing that we need to do to solve the problems based on MPC. So we know that the formula of Z is x minus m by sigma. Our raw score is 65 and the other raw score is 55. So when we take raw score as 65 using this formula, we can have the Z value or standard score value as 1 sigma. Similarly, for the Z score for x equal to 55, from the formula we have Z equal to minus 1 sigma for x equal to 55. If we want to locate this particular 1 sigma and minus 1 sigma in the normal probability curve, we can see that mean is in the middle and plus 1 sigma is at 1 sigma standard unit in the right hand side, and the minus 1 sigma is 1 standard unit in the left hand side. So this 65 and 55 falls on these two particular points. So if we see this particular case in this particular normal probability curve, we can see that this particular area under minus 1 sigma to plus 1 sigma can be represented by this blue part. So in between this blue part, that is in between the score 55 to 65 or in between minus 1 sigma to plus 1 sigma, this blue part represents the percentage of cases. We also know that in between mean and 1 standard deviation or 1 sigma, we need 34.13% of cases lies. So if we take together in the left hand side and in the right hand side, each 34.13% of the cases lies. So overall we can say that 68.26% of the cases falls in between the score 55 and 65. So we got the answer of our first question, that total percentage of cases in between the score 55 and 65 is 68.26%. Okay, now we will solve the second part of the problem, that is percentage of cases falling above 70. So here also we have got a raw score 70. So again we will use the Z score formula, that is x minus m by sigma, and putting the value here we get, that is when our raw score is 70, the mean is 60 and sigma is 5, we get Z value as 2 sigma. So if we want to see this 2 sigma in the normal probability curve, we can see that this particular value falls here. This is the point of 2 sigma. Also we know that 34.13% of cases lies in between mean and 1 sigma, and also 13.59% of cases lies in between 1 sigma and 2 sigma. We also know that 50% of the cases are in the left hand side of the curve. So to solve the problem, first we will find out percentage of cases below 2 sigma. So we can notice from the figure, percentage of cases below 2 sigma is 50 plus 34.13 This 50%, 34.13 and 13.59%. So in total 97.72% cases falls below 2 sigma. So to get percentage of cases above 2 sigma or 70 is, we know that total percent of cases is 100. So we'll minus 97.72% from 100. So we got the value 2.28%. So percentage of cases above 2 sigma is 2.28%. So our answer to the question is percentage of cases falling above 70 is 2.28%. Now we will solve the third part of the problem, that is finding percentage of cases below 45. So again we will use the Z-score formula. So from the Z-score formula, when x is 45, mean is 60 and sigma is 5, we have Z equal to minus 3 sigma. So if we want to see this minus 3 sigma on the graph, we can see that it lies here at this particular point. So we have to get the number of cases below this point, that is here, lying below this point. We know that 50% of the cases lies in the right hand side. Also in between minus 3 sigma and the mean, 49.86% cases lies. So in total, if you want to see, 99.86% cases lies above minus 3 sigma. So percentage of cases below minus 3 sigma or the score 45 is 100 minus 99.86%, that is 0.14%. So this particular score lies here below this minus 3 sigma. So our answer is 0.14%. So percentage of cases falling below 45 is 0.14%. You can see here. So now we will see second application of normal probability curve. The second application of normal probability curve is to determine number of cases lying above or below a given score of reference point. To understand this particular application, let us take one example. An intelligence test was administered on a group of 800 cases of class 6. The mean IQ of students was found to be 100 and SD of the score was 15. Find how many students of class 6 having IQ below 90 and above 120. So here we are going to determine number of cases, not percentage of cases. We are going to see number of cases lying with a point of reference. So here in this particular problem, we have to get how many students of class 6 having IQ below 90 and above 120. So let us see how we will use normal distribution properties to solve this particular problem. So let us start solving this problem. Let us take two reference to score, x1 equal to 90 and x2 equal to 120. So first of all, we will solve for x1 equal to 90, that is number of students below the IQ level 90. So we will use the formula for Z-score. We know already what is the formula for Z-score, x minus m by sigma. So putting the value of mean and standard deviation, we get Z value as minus 0.67. So if we want to locate it on normal probability curve, we can see that this particular minus 0.67 will lie in the left hand side of the mean. This particular place, minus 0.67 value will lie. And we already know that the mean value is 100 and x1 is 90. So we have to get this particular value below this score of x1 equal to 90. So this shaded portion represents the students lying below the score of 90 or below the IQ level of 90. So we need to find out the number of students lying in this particular area. So this particular number of students, if we find out, we will get our answer. For the first part, for the IQ level 90, the number of students lying here. So let us interpret it from the NPC table. We have got this NPC table and we know that the mean lies at the center and 50% of the cases lies in the right hand side. Also, if you follow the NPC table as we have already discussed in the earlier part of the video, we can see that 24.86% of cases lies in between mean and 0.67 sigma. So we need to find out percentage of cases in this particular shaded region, that is below minus 0.67 sigma. Hence percentage of cases below the point minus 0.67 sigma or score 90 is 50, that is remaining 50% in the left hand side, minus 24.86%, that is 25.14%. As we already know that the number of students in this particular problem is 800. So 25.14% of 800 is 201.12, or approximately 201 students. So we can say that 201 students IQ score falls below 90. So we have solved the first part of this particular problem, that is number of students below the IQ level of 90 is 201 students. Now let us solve the second part of the problem. So here x2 equal to 120. We will use the z-score formula for mean equal to 100 and sigma equal to 50. So from z-score formula x minus m by sigma, we get z equal to plus 125 sigma. If we want to see this particular point in the normal probability curve, we can see that this point lie here. So we need to get the number of students lying in this particular shaded portion. So this particular section represent area above score 120, or number of students lying above score 120 or above IQ score 120. So let us interpret it from the MPC table. As we can see in the MPC table, 50% of the cases will lie in the left hand side of the graph, and as our reference point in our problem is plus 1.25 sigma. When we see from the table of area, we see that 39.44% cases fall in between mean and plus 1.25 sigma. So we need to find out number of cases above this point or in this particular shaded region. So we can find out percentage of cases above the point plus 125 sigma or positive 1.25 sigma can be given by 50 minus 39.44%. That is 50% of the right hand side minus 39.44% up to plus 1.25 sigma. So remaining is 10.56%. Also, as we know that total number of students are 800, we can find out 10.56% of 800. So we get 10.56% of 800 as equal to 84.48 or 84 students. So in this particular reason, 84 students are lying, or we can say that 84 students are having IQ level above score 120. So now we will see the third application of normal probability curve. The third application is to determine limits of scores which includes a given percentage of cases. So here we are going to determine limits of scores or scores. So in the first one we have determined the percentage of cases. In the second one we have determined number of cases. And here we are trying to get the scores which includes a given percentage of cases. So we can understand this when we will see one problem. So let us see one problem. Here is one problem. As we can see, an achievement test in science was administered to 100 students of class 7. The value of mean and sigma was found to be 50 and 10 respectively. Find limits of score in which middle 75% cases lie. So here we have got a particular percentage given, and we have to determine the scores within which this particular percentage of cases lies. So we have to get the raw score within which the 75% cases lie. So let us see how we solve this problem. So let us solve this problem. So what is this middle 75% means? So we can follow from this normal probability curve. This is the mean point or the line from where the mean passes or the line on which mean lies. And we can see that 75% cases are lying here. So 75% of cases are lying in between it. So if we can see this 75%, if you divide it, so 37.5% cases in the right hand side and 37.5% cases in the left hand side. So this is the scenario. So we can say that 37.5% cases each in both the left and right of the mean. So actually in this particular problem, we need to find out this particular Z values. So first we have to determine the Z values so that we can get the raw scores. So let us try to find out these Z values. Let's see the situation in the graph. We can see that the mean is in the middle and 75% cases are spread like this. So if we follow the NPC table, because I already told you that we need to use the NPC table where we can get the particular percentage of cases in between particular sigma values. So if we follow the NPC table, we can see that the Z value at 37.5% is positive 1.15 sigma. So Z1 will be plus 1.15 sigma and Z2 will be minus 1.15 sigma, because 37.5% cases are lying in both sides, in the right hand side and in the left hand side. So these two particular values are plus 1.15 sigma both in the positive side and in the negative side. We can see that this particular point is plus 1.15 sigma and the other point is minus 1.15 sigma. So we have got two Z score values. Now if we have got the Z score values, we also have got the mean value as 50 and sigma is our 10. So using the Z scores and mean and sigma values, we can go to the raw score. Let us do it. When Z1 is plus 1.15 sigma, using the formula of Z score x minus m by sigma, we have x1 equal to Z1 sigma plus m. So solving this, we can get x1 as 62. Round it to 62. So this particular value at plus 1.15 sigma, the x value is 62. Similarly, when Z2 is equal to minus 1.15 sigma, using the same formula, we get x2 equal to 39. So here the value as minus 1.15 sigma is 39. So we have got the two raw scores. First one is 62 and the second one is 39. So we can say that the 75% cases lies in between the score 39 and 62. So we have solved this problem of finding out scores under which a particular percentage of cases lie. So now we will see the fourth application of normal probability curve. So the fourth application is to compare the two distribution in terms of overlapping. So we can see in this particular graph, if this particular situation arises, overlapping situation, so in that particular situation, what is the use of normal probability curve? So once we will take one example, we will be able to understand. So the problem is a logical ability test was administered on 300 science graduate boys and 200 science graduate girls. So here 300 science graduate boys are there and 200 science graduate girls are there. The boy mean score is 26 with SD of 4 and the girl mean and SD is 28 and 8 respectively. Find the total number of boys who exceed the mean of girls and total number of girls who got score below the mean of boys. So we have got two problems within this particular problem. First one is to get the number of boys who exceed the mean of girls, that is 28, and total number of girls who got a score below the mean of boys, that is below the mean of boys, that is below the mean of 26 of boys. So how you are going to solve this one, let us see. Let us first try to understand this problem in a graph. So suppose this is the normal probability curve and this is the normal probability curve of the boys. So mean is 26. So this is the curve for boys, the mean is 26. Now we have got the mean of girls as 28. So suppose this is the graph of girls with mean 28. Now according to the question, we first have to find out the number of boys scoring above the mean of the girls. So this is our first question, number of boys above the mean of girls. And in the second question, we have to find out number of girls who are scoring below the mean of the boys. So this is the second situation. We have to find out number of girls below the means of boys. So first question is about this orange shaded part, that is number of boys above the mean of girls. And the second question is to answer this about this green shaded part, where we have to find out number of girls below the mean of boys. So we'll see how we can do it. So we will solve the first part of the problem, that is number of boys exceeding the mean of girls. So this is the question under discussion. The first part, we have to find out the shaded portion, this orange part, that number of boys having score above this point, that is 28. So let us solve it. Boys mean equal to 26, sigma is 4. Point under consideration is 28, that is girls mean. So when x equal to 28, we can have the z score as 0.5 sigma. So now we can follow the NPC area table. From there we can get percentage of cases from mean of boys, that is this particular point to this particular point. We can get that number of cases are 19.15%. But we have to find out this particular part. So in this particular part, percentage of cases will be 50 minus 19.15%. That is 30.85%. We also know that number of boys are 300. So 30.85% of 300 is 93 boys. So in terms of numbers, we have got 93 boys, those who are above the mean of girls. Now to solve the second part, to find out number of girls below the mean of boys, in this particular question, we have to find out number of girls lying in this particular area, this green portion. So here girls mean, we know that girls mean is 28, sigma is 8. Point under consideration is boys mean, that is 26. So if we take this particular 26 as x score, we can have the z value from the z score formula minus 0.25 sigma. And when we see it from the NPC area curve, we can see that percentage of cases from mean of girls and minus 0.25 sigma, that is this particular value and this particular value, is 9.87%. So we have to consider this particular section, not this particular section. So in this particular section, what is the remaining percentage of cases? So we can see that percentage of girls below boys mean can be obtained as 50 minus this 9.87, because this total is 50. So 50 minus 9.87%, that is 40.13%. So as total number of girls are 200, we can find out 40.13% of 200, that is 80 girls. So 80 girls are there who are lying below the mean of boys. So we have solved the second part of the problem also. Okay friends, so in this particular video, we have seen different application of normal probability curve. You must have seen the various application of normal probability curve. You must have also realized the importance of standard score or Z score. How important it is to solve problem based on normal probability curve. Also, it is important to understand the percentage of cases distribution under normal probability curve. You must have seen that in various problems we have gone to this particular table to understand or to get percentage of cases under a particular Z score value. So it has helped us to get percentage of cases in between mean and a particular Z score value. This percentage of cases can also, in the reverse direction, can also give us the Z score values. So these two particular things, the Z scores and percentage of cases under the NPC table, is very much important to solve the problems based on NPC. In this particular video, we have discussed 4 applications of NPC. In the coming video, I will continue with the application. I will discuss some more application of normal probability curve. I hope you have liked this particular video. So press the like button. Also subscribe to my channel and keep watching.